Welcome back. In this today's stream I will be working on a solution of a problem where we are going to print all the sub arrays of an array in a sequence of all the possible sub arrays of an array. That is the real problem. For example, if we have an array of, for example, 1 2 3 4 5, then we need to print 1 1 2 1 2 3 1 2 3 4 1 2 3 4 5 2 2 3 and like that. So these are all these sub arrays are all the possible sub arrays of this array, and we have to print that. And how are we going to do that? For example, if I take an array of 3 integers, for example 1 2 3, sub arrays are going to be 1 1 2 1 1 2 3 2 2 3, and at the end it is going to be 3. So how many sub arrays do we have? If we look at it, we have 3 to 5 and 6 sub arrays. So the number of sub arrays starting from a particular position, like first, second, third, is total is equivalent to length of the array and minus, you can say that 1, and so something like that. For example, for the number of elements starting from first position has 3 arrays, and array has length of 3. Number of sub arrays from index starting from our second position, we have 2 arrays, 1 2, and if we start an array from here, we can see the number of elements are going to be 2, so we have 2 sub arrays. And if we consider last element as a starting of a new array or sub array, we can see that only one element is possible because the length of array at this point is 1. So how can we calculate the total number of possible sub arrays of an array? So we can say that if length is n, then all the possible sub arrays are n minus 1, n minus 2, n minus 3, and like that. So we have 3 plus 2 plus 2 plus 1. So you can see that we have 3 plus 2 plus 1, we have 6 sub arrays. For array of size of 3 is equal to 6. Similarly, for array of size of 5, we have 5 plus 4 plus 3 plus 2 plus 1 is equal to 5 5 10 15. So we are going to have 15 sub arrays for array of size of 5 elements. And similarly, for array of size of 6 elements are going to be 6 plus 5 plus 4 plus 3 plus 2 plus 1 is equal to 21. So this is how number of total sub arrays, possible sub arrays are going to be calculated for an array. So how can we calculate that? We can write a function static int possible count of sub arrays is equal to final int array length, and I'm going to have a sum variable is equal to 0, return sum, and I'm going to say count is equal to array length. While count is greater than a 0, sum plus equal to count minus minus. So what is happening? We are basically doing this operation that we are adding this count to the sum variable and then decrementing it. This is postfix uh, postfix decrement operation. So this count value will be read and added in the sum, then the count value of the count will be decremented. So if array length is 5, it will start from 5. First 5 will be added to the sum and count becomes 4. In next iteration sum is 5, so 4 will be added to it and now it becomes 9. So like that we are going to using this formula to calculate the total number of possible subarrays of an array. Next is, we have to visualize this problem in a way that when we say subarrays of an array, possible subarrays of an array, we can imagine that all these arrays are independent. We have given these different independent arrays and we are going to print it. So but that array all are coming out of this array. So when I say look at this array with one element, this one, I can say the start and end index of this array is 0 0. I can say that in this case the start of array is 0 and end is 1 index. In this we can say the start is 0 but end is 2 because 3 is occurring, this value is occurring here at second position. So if we move down, for example, if we look at here 2, we can say that for this subarray the starting position of this subarray in this array is 1 and ending is also 1 because this is one element. In this array starting is 1 and ending is 2. So this is what we are going to print when it comes to printing this subarray. So what are you going to have? I am going to write a function static int print and it will need an array of integer, array of any other element, and it is not going to return anything. I can say final int total, I can say total ints is equal to ints dot length, last valid index is equal to total ints minus 1. This will show that our end of iteration has end of array has come. For example, if in this case if we see at 3, so there is nothing beyond this value, so end is going to be 0 1 2. So when we reach over here, we can say that the start and end is both 2 and the last valid index is also 2. So we know that we have iterated entire array. So now we have to stop. These are two values that we are going to use, and what else we are going to need is we are going to need an array integer value to store array start index, which is currently 0, array end index, which is also 0. Why 0? Because we will be starting from the first element, and first subarray is also always going to be a single element. And we are going to have another variable called current index, which we are iterating, is also going to be array start index. So there from that index we have to start, and next is going to be int total arrays, total number of sub arrays is equal to count of arrays and total ints. So I will say while total number of sub arrays are less than 0, greater than 0, that we still have sub arrays to print. So as long as this value is not a 0, we will keep iterating over that array. So I will say percentile d space, and I will say ints current index, print it. It is printed. After printing, I will check if index has reached the array and end index, that if we are looping over this value, I will have to check that have I reached the index end of this index. So start of this index is 1 and end of this index is also 1 for in this case. So we will have to validate that. Once we do that, I will have to check array index has reached the last valid index. That means the last valid index is this 0 1 2 2. So when we reach the last valid index, then we know that we have to move the start index to next index. So early from here the start index is 0, here is also 0, here over here it is also 0. So when we reach the last valid index, we know that the start index has to move to the next element, that is 1. So we increment the start index and start iterating from index 1 and print 2, then 2 3. Similarly, when we find that array end index is equal to last valid index, then we need to move the array start index. So once the array start index has been moved to next index, that from 1 to 2, we need to reset the end index to the start index, because we will be printing only one element, then 2 element, then 3 element, like that. So the end index, that is array end index, need to be set to the start index. So we have reset our array, or we can say that we have chosen a block of array in the block of sub array in the given array. Once that is done, we have to move to the next case, where, for example, if array index hasn't reached the last valid index, then what do we need to do? In that case, we will just increment the array end index, and the current index will be moved to array start index, that is start from 0, start from the start again. So when if, for example, array index reaches this at position 1 or prints 2, we are checking that the end index hasn't reached the last index. So we increase the end index to the next index, that is last index, and we set the current index to start from the beginning, that is the start index. So we are setting the current index to start from the beginning of this current subarray. Once that is done, we have to decrement the total number of subarrays, because once we have reached the current end index, then we have to start the new loop. So this this subarray has already been printed, so we need to decrement that. So current index is reached the end index, end of the current subarray, and we check that if we can move the array index subarray, can we extend it towards the right? If it is not possible, then we move the start towards the right and move this set the end index to point to the beginning of the subarray. If we have more spaces left to cover, we move the array end index towards the right, so that we can print those elements which were not printed in the last iteration again, starting from the beginning. So this covers entire loop, and once a loop is printed, we can add a new line to separate those elements, separate those lines. I think this is the code that is we have written, and it should work. Let's call it. Let's say print ints and run it. Something went wrong, let me check. So we are checking the current index has reached the array index or not, right, that it has reached the end. Then we do the following operation. So in the cases where it hasn't reached the end, or it hasn't printed all the elements in the current subarray, then what we need to do is the normal operation that we move the index forward. the current iteration index forward. That if we have for in this subarray, if we are printing this subarray, if I check that and my current, if I printing this subarray, I printed the 1, then I check that has my current index reached index 2. It has not. So current index has to print the value 2 or index at position value at position or index 1. Then I increment the current index to move to this value, so that we can print 2. So that was the missing part. So let me run it again. So that we can see that our sub array has been printed, and you see that 1 1 2 1 2 3 1 2 3 4 5 1 2 3 4 5 like that. And let me make more changes to make it more clear. For example, if I want to separate these sub arrays with different start indexes or different start values, then we can do that also. Array index and array index, large index, and move the front. Then I can say this out. Let me run it again. It needs a little bit of change. I can just move it to the top. Now you can see that I have separated different subarrays which are starting with which have different value, or I can say that I have grouped subarrays in groups where the subarrays start with the same value. So that is all subarrays starting with 1 are printed in one group. All sub arrays starting with 2 are printed in one group. All sub arrays starting with 3 is printed in one group, and like that. So if I increase, put more value here, if I say 6 7, how it is going to handle, let us see that. So without any error, we are seeing that we have printed each and every possible sub arrays of all the elements in this array. So what is the time complexity now? If we want to know what is the time complexity, so if I go back here, you can see that in this part 1 is printed 3 times. Wait, 1 2 3, 2 is printed twice, 2 2, and 3 is printed once. And if I go here and let me and go back here and say, and if you say we have total of 7 elements, you can see that 1 has been printed 7 times, and 2 has been printed 6 times, 3 has been printed 5 times, 4 has been printed 4 times. So you can see that the number of elements, number of times a single element is printed. For example, 2 has been printed, for example, if you see it, 1 has been printed 7 times. So here 6 has been printed 6 times, that is 1 2 3 4 5 6, and over here 6 has been printed 6 times, so it is 12 times 12. And if you move forward, I can see that 3 to 5 10 15, and over here if we say 4 8 12, so 4 and 16, 4 has been printed 16 times. This is the value, this is the current operation. So if I can say with size 7, 1 is printed 7 times, right? Okay, with size 2, sorry, 2 has been printed 12 times. Three has been printed 15 times. Let us see what value we can find from here. 4 12 16, 4 8 12 and 16. 4 has been printed 6 16 times, and 5 has been printed 1 2 3 4 5 25 times. 1 2 3 4 5 6 and 6 has been printed 12 times. 7 has been printed 7 times. You can see there is for example, if I double it, if I for example, if I go from 2 to 4, for example, if I have elements, only 2 elements in the array, one is printed twice, 2 is printed twice, right? If I make it 4, 3 4, so with 4 elements, one is printed 4 times and 2 is printed 4 times, 3 is printed 1 2 3 6 times, and 4 has been printed 4 times. So you can see that if I compare with the number of with array of size 7, this number of times 4 has been printed is not increasing with the same magnitude that the size is increasing. For example, 4 is almost double of, for example, if I double the 8, make it size 8, the number of times one is going to print it is 8. So you can see that the dependency or relation between the number of times and value in the array is accessed or touched or read depends on the length of the array, that is n, right? Not n square. So the for example, if I open the Firefox, let me see the, so dependency is not the number of times an object in an array is read is doesn't depend on the square of n. So this is definitely not O n squared. This is this depends on n. For example, depends on n, O of n with some constant multiplied with the n. So this is done in a linear time. Entire this process that we are printing all the subarrays of an array in linear time. For example, if I go from 17 to 14, if I double the, for example, size of the array, then for dependency the number of times the element should be read should be square. For example, if I make it 14, the number of times one should print is 49, so which is not happening. Number of times one is going to print it is 14. So there is a linear dependency from the time complexity of this algorithm is linear. From here we can see that. I will say graph of x square so this is the graph of x square. This is how graph, if this is the number of elements in the array, then this is the number of times one needs to be printed. So it is, if it is for example number of array, sorry, x, if number of elements are 6, the number of times 1 is printed 36, and number of let me go to 12 twice. So number of times, the number of elements in the array is 12. The number of times a single element in the array, or integer in integer array, or some value in some array should be printed 157 times, which is not happening. So this is not depending, this is not a quadratic time complexity, this is linear time complexity. Hope I was able to make things clear, and this is my solution to print all the subarrays in linear time. And see you in the next video. Thank you for watching.